Welcome back to week 4, and in video 2 we're going to continue with streams and talk about how streams erode, transport, and deposit sediment. So how do streams erode material? Well, this is directly related to the velocity of the water and what's in the water, and what the bed of the river is composed of. So the faster the water moves, the more energy it has, and that means the bigger the particle that it can carry and the more particles it can carry. So really fast moving water can carry lots of mud, sand, and even pebbles up to boulders, depending on how fast that water is moving. Erosion can take place by those particles that are being carried, bouncing along the bottom, rolling along the bottom, scraping along the bottom of that river channel, and actually abrading the rock below, abrading the bed of that river. Sometimes the actual water flow can create what's called hydraulic lifting and take parts of the bedrock and basically just rip it off based on that water flowing past that point. When we transport that sediment, we can transport it in 3 different ways: bed load, suspended load, and dissolved load. And then the deposition of water, again, just like erosion, is directly related to the velocity of the water. So as that water slows down, and maybe it enters another slower river, enters a lake, any kind of calm body of water, that river water is going to slow down immediately, lose its energy, and then it can't carry those sediments anymore, and they're going to become deposited. So just to kind of show you the abrasion that can happen, this is in Canyonlands National Park in Utah. So this channel that you see here only fills up maybe once or twice a year for maybe a week, because this is a dry environment, and it only fills with water when you have a major rain event, which rarely happens in this area. So basically you can see these little potholes that are developed because the bed of the river is bedrock, and we have the river, when this fills with water, it's moving pretty fast. You can carry boulder sized particles if it's going fast enough. It might carry pebble sized particles that are going to roll around in these little potholes and then slowly abrade that surface and break it down and then create these potholes. So these are going to get larger and larger over time. We can also have dissolution, so we have minerals dissolving by chemical weathering as the water flows through. And we talked about that dissolution process when we talked about sediments and sedimentary rocks. So if you're confused on what dissolution is, make sure you revisit that. So some of the ways this material can be transported, well, we've got the bed load. So this dark brown triangle shape is the bottom of the river bed. The bigger kind of tan chunks would be maybe pebble, gravel sized, or boulders that are moving along the bed of the river. So they're staying in contact with the bed of the river. So that means they're touching it, maybe they're bouncing off of it, they're rolling, they're sliding. And then we have the suspended load, which never comes in contact with the bed of the river. It stays suspended in the water column. Things like muds, fine sands would be a good example. And then you have dissolved load. So that's the stuff that gets dissolved through chemical weathering. And here you can see, kind of zoom in, magnifying glass, and we have some of these ions that are dissolved in the water. So those are the major ways we can transport sediments from place to place in a river. So what are the major stream types? So we have all this erosion, we have sediment transporting. We have 3 major types of streams. We have braided streams, straight streams, and meandering streams. Each of these, for each of these that we're going to visit in the next few slides, we're going to relate each type of stream to the types of sediment or rock that it moves, and then I'll talk about how each of these streams and the pattern change in relation to age. So the first thing we're going to look at is straight, and straight rivers tend to be the youngest. So these are youthful streams. They've had some kind of recent erosion. So here is a good example. It's fairly straight. You can see it has some bends in it, but you're not going to have a dead straight river. It just doesn't happen unless you've had some kind of man-made structure helping to channelize or divert that river. So straight means relatively straight. So these are relatively young. They tend to have a higher velocity. Your gradient tends to be much higher because these are really young. They're flowing in usually somewhat high alpine areas. In this case here, Idaho. This isn't a high alpine area, but you can see it has a very steep river channel. We have these very steep sides on either side of that river. You can see it has rapids present, and it's pretty straight. It has this was a very, very fast moving river. So this kind of river is going to be able to transport pretty much all grain sizes, small to large. It's during high flow periods, it can probably move boulders, but during lower flow times, the largest would probably be pebble or cobble. You can see here, if this river were to flood, it's not going to flood very far. It's constricted to the sides of the steep valley, and this one only has rapids, but you can sometimes see waterfalls too. So we're going to take a look at a straight stream, an example in Google Earth, and what I've got for you. So we'll take a look at the white salmon. The white salmon is a good example of a fairly straight river. I'm going to take off places in the photos here and the borders. So the White Salmon River has a couple bends in it, but it's fairly straight, we can say. It's not really windy. The Hood River would be another example of a fairly straight river. It has a couple bends, but overall it's fairly straight. We don't see a really sinuous pattern. So the next stage, so if this river were to be allowed to erode for maybe millions of years, it could eventually get to the next stage, which is either braided or meandering. And the difference between these two, braided are sometimes considered middle, maybe mature, kind of depends on where you are. Braided rivers have a high degree of change, and here you can see that what that one of those channels would look like. It has intertwined paths in it that kind of divert and go around what are called channel bars within the river channel. These have a moderate gradient. They vary in discharge and velocity. In some wetter months, it's going to have a higher discharge, higher amount of water flowing. It can carry more particles, so we have a lot of change, a lot of erosion that happens. Once that discharge decreases, the velocity slows down, the river stops carrying all those particles and deposits these channel bars. So we can have small to large particles, and that can change, like I said, with discharge. An example of what one of these looks like, you can see them in Alaska. If we flow over to Alaska, you see these a lot at the mouths or the toe end of glaciers. You just kind of zoom out a little bit here. You can see that we've got a couple glaciers flowing into this area. When we zoom in here, we can see that those river channels have an extremely braided pattern to them, because in the springtime, lots of glacial runoff, so the velocity of the water increases, and discharge increases, so we have more sediment transported. But in the wintertime, things start to freeze. We don't have the amount of glacial runoff, so discharge decreases, sediment gets deposited, and we see these braids. So it changes. This river is going to change every year. It might be in a different place, which is pretty neat stuff. So our next, if we kind of compare our braided to our meandering, let me just show you real quick what meandering looks like. Meandering, we have super sinuous pattern in our channel, back and forth, really, really windy pattern. So these would be late or old stage. Mostly clay and sand transported. During flood season, you can have larger particles transported, usually relatively low gradient to be able to get those meandering channels. And in meandering river channels, the erosion is more focused side to side and not as much focused on the actual stream bed, whereas in braided and straight channels, most of that erosion is focused downwards. So we tend to have these meandering channels. We can see oxbow lakes, wide floodplains present. And to show you an example in Google Earth of a meandering river. We'll go to the Mississippi River eventually over here, and you can see how sinuous and windy that pattern is, and a couple little oxbow lakes off to the side. When we talk landforms, I'll get into how those oxbows are formed. So to talk kind of the difference between meandering and braided, these can actually become each other over time. The difference here, with the more braided channel, we're going to have more bed load, more material moving along the bed of the river, whereas in the meandering river channels there's more suspended load. Grain size, finer for meandering rivers, coarser for braided. And then the stability of the banks, so how stable are those river channel banks, so these channel bars in this case, these bars on the inside of the bends, they're more stable meandering because that doesn't change quite as much as the braided. Braided changes every year, so pretty decreased amount of stability over here. And then variability, same idea, high amounts of variability every year, things change. Meandering, a lower amount of variability. And then channel slope, meandering, pretty low. Braided can be moderate to high. So those are our differences between those two. So eventually over time, if we have a braided river channel that maybe the variability decreases, it can eventually over time turn into a meandering river. So meandering river is going to be the oldest stage. So those are some of the major types of streams and how streams erode and transport material. We'll come back and we'll get into the major landforms that are created.